Yes, I see your screen.
Perfect. Then I will start. First, I want to introduce myself. I'm working for Austro Engine since 8 years now. Since this year, I have the role of the lead design engineer. I started in the design department, and now I am responsible for the engineering team and the testing team. I will introduce next my company, what we do. On the first slide here, you can see that we are in the aviation business. We are an engine manufacturer, producer for Diamond aircraft. And Austro Engine also belongs to the same owner as Diamond aircraft. So we are within the same group. We will see it in the next slide. So this is what I want to talk about. It's my company here, Austro Engine, in this building I'm working. Then I will show you some products we develop and the projects we already accomplished with CETOL Six Sigma this year. And then, if there is time, I will show you some products of Diamond Aircraft, the company we are delivering these engines we are building. First, this is where the Diamond Aircraft building was founded in 1989. You see here, this is how it's all started. In this year, I already was not born, so I cannot tell you what exactly happened with the area at the back side, but on the right side here, you can see the whole buildings of Diamond Aircraft located around the airport. The small company at the bottom right side, this is Austro Engine. It's located also very close to Diamond Aircraft. We have three different manufacturing locations in Canada, then in Wiener Neustadt, this is where I am, and in China. This is all for aircraft manufacturing. All the engines are coming from Wiener Neustadt and from Austro Engine. So we have to deliver to the whole world our engines. In 2007, Austro Engine was founded. This was the reason why the former company owner wanted to build his own engines. He didn't want to rely on our competitors now. He wanted to build the aircraft completely on his own, also including the engines. Out of quality reasons, he decided to found the company Austro Engine. In the year 2009, the company Diamond Aircraft developed the twin engine aircraft, and also included there was our engine. So 2 of our engines are installed in the DA42. The time limit of the engine at that moment was just 1,000 hours. Within 2012, this was extended to 1,200 flight hours. This TBO here means time between overhaul. This is familiar for aviation business. This is the time till the engine needs to be replaced. And with continued accumulation of flight hours, we were able to extend this TBO to 1,800 hours in 2015. Yeah, in 2016, the whole fleet flight hours were over 1 million. So this is one big target we had to show the durability of that engine we have. In 2016, the company was bought by our now Chinese owners. We are part of the Wanfeng aviation industry. Since then, we had the big challenge to build the engine on our own, because before Wanfeng bought Austro Engine, the engines were produced at Daimler. It's a Mercedes engine originally, the core engine, and out of they ran out of stock because this engine was not produced anymore. So we had to focus on building or rebuilding this engine. We have bought the license rights from Daimler with all the drawings, CAD models, and calculation results, all what they had in their engineering department. And since then, we were able to improve slightly the design, but for aviation as less as possible that was the target. So as less changes as possible, because out of certification reasons, you have to re-qualify everything if you change something. And yeah, this was done in 2019, where we delivered our first engines built from the re-engineered data, I would say. Here you see one of the smaller engines we have. It's a rotary engine. It's used in small sailplanes and rotorcrafts, unmanned rotorcrafts. The main benefit of this engine here is just the weight to power ratio. It's very powerful for its weight, and it can be installed in any direction. So there is no need for an oil sump or something like this for lubrication. You can tilt it 90 degrees up or what you want. There is no special need for installation direction. Then we have this engine, this rotary engine with two combustion chambers. It's a little bit more powerful, also re-engineered housings and focused on weight saving and durability. And yeah, these two engines are F-gas engines. They are powered with gasoline. And yeah, this is something that needs has a less efficiency than the engine I will show you next. This is our main product. This is also the engine that is installed in the big aircrafts from Diamond. This is the Daimler engine, re-engineered by Austro Engine. Yeah, it has a displacement of 1.9 liters. We have it in two power classes. One version is with 170 horsepower, one with 180. It's just a software difference. The main hardware of the engine is still the same. And it has a weight of 186 kilogram. It's due to the automotive engineering data, and there is nothing considering weight saving. It's a very heavy engine block made of gray cast iron, and we will try to improve this in the next years. I think hopefully we will achieve a lighter version of this engine, but so far the reputation of the engine is good. The flight hours are now also raised to 1,800 till the engine needs to be replaced. Yeah, this is what we achieved in the last few years. Yeah, but now I will come to what we did this year with CETOL, the more interesting things. I can imagine you are all waiting. As I said, we are a very small engine manufacturer with less than 1,000 pieces a year, and our engine came from Mercedes-Benz. So most of the production processes are not focused on this low amount of parts. We had to change very, very much drawings due to manufacturing processes. Also, many tolerances need to be recalculated for all the needs the manufacturers had for us, so the suppliers. And for this, we had to be very, very quick. So I'm very happy that we got the approval for CETOL, because it helped very much for our engineering department. Before this, we worked with spreadsheets, and it's not practicable with that amount of changes we had. This is not the way it should be. It needed more and much of resources. So with CETOL, I was just one. I calculated what was necessary, and this we will see the next. I will show you here an oil pump of our internal combustion engine of the oil circuit. We had to change here the manufacturer of the housing. And with this manufacturer change, there came also the first problems, some deviations on the housing due to that the manufacturing or the machining process of this housing. The clamping was different, the casting was different, and so we had the project to prove that the part is also reliable with these deviations. So I prepared the CETOL as model. I implemented all the tolerances we allowed on the drawing, and then I calculated what tolerances are still acceptable. Just focusing on the lubrication, on the gap between gear and housing, so that there is no clash or material that is removed by the gear, because this would harm the engine. And with CETOL, we managed to select these parts that are that were still usable, with focusing on safety. This is the most important thing when we do such non-conformance report. We want to avoid that there is a huge problem after releasing those parts. And for this, CETOL indicated that we are still on the safe side. There is no possibility of gap of a clash. We still have a gap of 31 micron, and so this is the mean value. And with this we released the oil pump, and also managed to change the drawings according to the supplier needs. So this was very helpful for us. This was the first project, first contact with CETOL, and I think everybody in our company was impressed what we can achieve with in such short amount of time. The next part I want to show you here is our cylinder head. There is a camshaft installed in the cylinder head. Oh, sorry. And this crankshaft drives the high pressure pump. And for the alignment of those two gears, we wanted to know which tilt angle between the installation also here created, and for angle that is possible here. And we see possible angle was 0.089 degree. So it's almost nothing with our tolerances we had. So we went to our gear manufacturer. He had the know-how to determine at which point of tilt angle it's critical for the gears. But with this low value, he said this is not critical. He also did a calculation with this tilt angle to show the pressure on the teeth surface, and it's confirmed that there will not be any problem or any issue with wear or pitting or so on. So in this case, we managed to determine quickly the possible tilt angle and deliver the input data for our gear manufacturer. The next thing here I want to show you is our crankcase with installed crankshaft. And part of this calculation was to determine the bearing clearance in the main bearings, because the bottom right section of my presentation, you can see the manufacturing accuracy of our manufacturer. This is something we developed for determining the manufacturing possibility of the supplier, and we also managed here in this case to determine non-conformances, the effect of non-conformances on the durability. We have a certain bearing gap or bearing clearance that we have to reach because of avoiding clash and still deliver enough oil for this bearing, for this sliding bearing. And this was also very quickly possible in this case. Yeah. Next thing we had was also related to gears and the wear process on gears. We calculated the tilt angle that is possible during installation and manufacturing of these parts. They are fitted together by pins. There are 2 pins located in the housing and in this cover. And by moving the position of the pin and the angle of the pin, the front bearing here moves slightly from side to side, and there can be a misalignment between back bearing and front bearing. So in this case, we are a little bit higher than with the high pressure pump. The previous model I showed you, or calculation, but still not very not bad for the gears, I would say. Has not a bad influence on the durability. This was just to determine how much is possible, also to get input data for the gear calculation. Yeah, and now my last sample here. This was something I calculated a few weeks ago. We had the issue with increased wear on some gears or some sprocket wheels, and I implemented here a calculation of the maximum displacement caused by positioning of the oil pump to the crankcase, also the movement of the oil pump gear here inside the oil pump, Here we have a press fit connection. So also here are some tolerances possible, some variation of the position of this gear. And also here the calculation indicated that it's more likely for the gear to move backwards and to the inside than to the outside. And so it's very clear why we see these signs of wear, because the gear is possible more to be displaced in the inner direction than to the outer direction. So CETOL here helped us to understand why our gears are more worn on the inside than on the outside. And with the possibility of indicating which dimension has the biggest effect on this tolerance chain, we managed to avoid these wear signs in future. We did a drawing change and adapted the tolerances according to that value from CETOL, Six Sigma, to also reuse these oil pump for overhaul engines, and yeah, thereby reduce costs, because we do not have to disassemble this pump here and install a new gear, because the old gear is still fine after the test runs. So we are very happy that we could achieve here such a positive improvement on the durability of this chain sprocket. And also here you see on the top side the camshaft with the camshaft gear. Also here we did the tolerance change to improve the wear situation. This is this camshaft to crankshaft has a little bit higher distance, so there is more possibility to avoid a high axial displacement. So the chain can compensate more displacement in this case for the camshaft. Otherwise, on the oil pump, you see the distance between crankshaft and oil pump is not that much as on the other parts. So here, a tolerance or a variation causes much more wear than on the top side. But also we did a tolerance adaptation on the top side on the camshaft gear. Yeah, what we got from our suppliers and also internally was that we managed a very complex topic, very complex tolerance analysis in very short amount of time, and that we can trust also the results of CETOL, because we've seen this on the test bench. And also it helps to secure the designs. We want to work and calculate more before begin of serial rollouts and serial introduction. So I'm driving also the calculations for new projects and before serial introduction, so we can see which tolerance we can increase or we must decrease to avoid any problems with those parts. Yeah. Now I can show you some of the products of Diamond Aircraft. This is where our engines are installed. This is a 5 to 7 seats aircraft in 3 rows, pilots and co-pilot. and then passenger seats. So this aircraft is available since 3 years. It has a very good reputation, and here you can see also the data of how fast you can go with it, how high you can go with it, how far you can go with it. This is the twin engine, biggest aircraft of Diamond. Then you have here the looking pretty similar, also twin engine aircraft, but here just 4 seats are in the cabin. This is also where our engines are used. This is the single engine aircraft. It's used most for training of new pilots. Training flight schools all over the world are using these engines because of low fuel costs in compared to gasoline engines. The diesel engine here used is more has less consumption and thereby more reliable. Yeah, and also we have here special mission aircrafts equipped with our engines. This is what we've seen first, the DA62, 7 seats, but with special equipment like the radar nose you see at the top, and flight radar at the bottom side, at the back side of the cabin. It's used for LiDAR measurements, for length measurements, and night flights to locate people or deer in the woods. It's used for special missions, I would say. Yeah, so I'm at the end of my presentation. I hope I could give you a feeling what we did with CETOL, and it was very good for us. I can just tell you it's more and more easier than using spreadsheets, and yeah. Then I will say thank you, and if there are questions, I look for questions. No, there are no questions, but you can also ask me if you want later.